take property 10. It states scalar product in terms of components. Let's see the scalar products in terms of its components. A vector B, A1 I vector, A2 J vector, A3 K vector, and let B vector be. These are the given things, right? So how it is located in the physical area? Like, let's see these two vectors, how they are depicted physical. Assume this is going to be the A vector, and something like this is like a B vector. Okay, these are in space and they are represented as ijk coordinates. Something like when you turn around, you can see x, y and z axis. Z axis is the one you can see here, center. Okay, so this A and B vector, you can see how they are located here. Okay, we are going to see the dot product of these things, and the x, y, z coordinate are like this here. A1, let's do a dot product. A1 multiplies into B1, A1I multiplies B2J, A1I multiplies B3K. So A1 B1 I dot I, A1 B2 I dot J, A1 B3 I dot K. Then let's take A2 multiply with B1, B2, B3 of K. So that's what we get here, A2 J dot B. Right, so any scalar dot product of any two vector like this, where it's represented by these things, it's called, okay, it's nothing but the direct product of their corresponding components. What is the component? A1 is the and B1 or the i's component, okay, and A2 B2 or the j's component. Okay, so this is the thing, and A3 B3 or the k's component. So that's all. It's nothing but the sum of their components. That is what is told. We saw this before. The property 11 is nothing but finding the angle between two vectors. That is how to find the angle between two vectors. Okay, let's assume, take the angles as A vector and B vectors. Okay, so they have a and the angle is nothing but theta between them. Let's think this is going to be the A vector and this is the B vector, right? So this we saw before. Then A vector dot B vector is modulus of A vector modulus of B vector cos theta. So cos theta is the one we need to find out. We found out this way. We brought the theta underneath, so theta is cos inverse of this one, right? So if A vector is represented in this ijk components and B vector in this way, then A dot B vector is going to be what? A1 B1, A2 B2, A3 B3. That's what we found, right? So modulus of A vector is equal to, per the rule, it is going to be the square root of the square of its components. What are the components? A1 square, A2 square, A3 square, and take square root of it. Okay, so that's what we do with modulus of B vector as well. If you need to know why, you have to remember that A dot B vector, you replace this A dot B vector with A dot A vector and you will know the answer. Okay, so here then we are left substituting this modulus of A and modulus of B vector in this sequence 1. Okay, so A dot B vector is, we found out this is A dot B vector, put this here, okay, and modulus of A vector and modulus of B vector, just substitute these values and this is what you get. So, and since you want to put the cos inverse, bring it down here, that's it. So we got the substituted equation. This is the way we found the angle between any two vectors, okay, where this any point is going to be given as ijk, okay. Somehow here it is going to be b1i, b2j, something like that, okay. So you remember this is the point.